You're standing in line at the grocery store, watching items glide past the scanner. There's a quick flash of red light, a familiar beep, and the price appears on the screen. It happens dozens of times during a single checkout, so routine that you probably don't even notice it anymore. But here's something you might have never thought to ask. Why is that light always red? Not blue, not green, not white, but specifically red. Every scanner, whether it's at a massive supermarket chain or a small corner shop, uses that same crimson glow. It's not random, and it's not just because red looks futuristic or catches your attention. The reason barcode scanners use red light is rooted in physics, engineering practicality, and the specific way barcodes are designed to be read. What seems like a simple aesthetic choice is actually the result of decades of technological development and careful optimization. Let's explore this right now. To understand why red light became the standard, we need to go back to where it all began. The barcode as we know it today was invented in 1952 by two graduate students, Norman Joseph Woodland and Bernard Silver, though it took more than 2 decades before the technology became practical for widespread use. The first product ever scanned with a barcode was a pack of Wrigley's chewing gum on June 26, 1974, at a Marsh supermarket in Troy, Ohio. That moment marked the beginning of a revolution in retail, inventory management, and supply chains worldwide. But early barcode systems faced significant technical challenges. The scanning technology needed to be fast, accurate, affordable, and reliable enough to work in the chaotic environment of a busy store. The choice of light source would prove to be one of the most critical decisions in making the system work. To understand why red light is used, we first need to understand what a barcode scanner is actually doing. A barcode is essentially a series of black bars and white spaces arranged in a specific pattern. Each pattern represents a number or piece of information, like a product ID or price. The scanner's job is to detect the difference between those black bars and white spaces as quickly and accurately as possible. When light from the scanner hits the barcode, the white spaces reflect most of that light back toward the scanner, while the black bars absorb it. A sensor inside the scanner, called a photodiode, measures how much light is being reflected. High reflection means it's reading a white space. Low reflection means it's reading a black bar. This pattern of light and dark is then translated into the digital code that identifies the product. The entire process happens in a fraction of a second, which is why checkout lines can move so quickly. Red light is particularly effective for this task because of how it interacts with the black ink used in barcodes. Black ink absorbs light across most of the visible spectrum, but it's especially good at absorbing red light. Meanwhile, white paper or packaging reflects red light very efficiently. This creates maximum contrast between the bars and spaces, which is exactly what the scanner needs. The wavelength of red light, typically between 630 and 680 nanometers, sits in a sweet spot where the difference between absorption and reflection is at its peak. If you used blue or green light, the contrast would be less dramatic because black ink doesn't absorb those wavelengths quite as completely. The sharper the contrast, the more reliable the reading, especially when barcodes are printed on less than perfect surfaces, crumpled packages, or items that are moving quickly past the scanner. Red light essentially makes the difference between black and white as obvious as possible to the sensor, reducing errors and allowing scanners to work even when conditions aren't ideal. There's also a technological reason that goes back to when barcode scanners were first developed in the 1970s. At that time, red lasers and red LEDs were the most advanced, most reliable, and most affordable light sources available. Early barcode scanners used helium neon lasers, which naturally emit red light at a wavelength of around 633 nanometers. These lasers were stable, bright enough to work in well-lit stores, and could be focused into a narrow beam that produced clean, sharp readings. The helium neon laser had been developed in the 1960s, and by the 1970s had become the go-to choice for applications requiring precise, coherent light. These lasers could maintain a consistent beam over distance, which meant a scanner could read a barcode from several inches away without losing accuracy. As technology advanced in the 1980s and 1990s, red LEDs and red laser diodes became alternatives for simpler scanners because they were cheaper, more durable, consumed less power, and generated less heat. By the time other colors of lasers and LEDs became technologically viable and affordable, red had already become the industry standard. Manufacturers had optimized their sensors, barcode printing standards, and scanning algorithms around red light, so there was little reason to switch. The infrastructure was already in place, and it worked exceptionally well. Another important factor is the sensitivity of photodiodes, the sensors that detect the reflected light. Photodiodes made from silicon, which are inexpensive and widely used, are highly sensitive to red and near-infrared wavelengths. Silicon photodiodes have a peak sensitivity range between 600 and 900 nanometers, which perfectly overlaps with red light. This means they can detect even small amounts of reflected red light very effectively, making the scanner more accurate and responsive. The electronic circuitry that processes the signal from these photodiodes was also designed and optimized for red wavelengths, creating an entire ecosystem of compatible, efficient components. If scanners used blue or violet light, they would need different types of sensors, perhaps made from different materials like gallium nitride that might be more expensive, less sensitive, or less reliable. Red light fits perfectly with the existing, proven technology that was already being mass-produced for other applications like remote controls, optical communications, and medical devices, keeping costs down and reliability high. Red light also has practical safety advantages. While the red lasers used in barcode scanners are classified as Class II lasers, meaning they are low power and generally safe, the fact that red light is visible to the human eye provides an important benefit. People can see where the beam is pointing, which means they instinctively avoid looking directly into it for prolonged periods. This visibility acts as a natural warning system. It's obvious when a scanner is active and where it's aimed. Workers using handheld scanners can see exactly what they're scanning, and customers can see when a scanner is being pointed in their direction. Blue or ultraviolet light, while potentially usable for scanning, would be harder to see or even invisible, creating potential safety concerns in busy retail environments where scanners are being used constantly around customers and employees. Invisible or difficult-to-see beams could accidentally shine into people's eyes without them realizing it, creating unnecessary risk. The visibility of red light makes the technology more user-friendly and safer for everyday use. The physics of how red light interacts with materials also plays a role. Red light has a longer wavelength than blue or green light, which means it scatters less when it hits irregular surfaces. When a barcode is printed on textured cardboard, plastic wrapping, or curved containers, the surface isn't perfectly smooth. Shorter wavelengths like blue light would scatter more easily on these imperfect surfaces, creating noise in the signal and potentially causing misreads. Red light's longer wavelength allows it to maintain better coherence even when bouncing off less than ideal surfaces, resulting in a cleaner signal for the photodiode to process. This is especially important in real-world retail environments where products come in countless shapes, materials, and surface qualities. A scanner needs to work just as well on a glossy magazine cover as it does on a matte cardboard box or a crinkled plastic bag. Interestingly, not all modern scanners still rely exclusively on red light. Some advanced imaging scanners use cameras with white LED illumination and can read barcodes in full color, including two-dimensional codes like QR codes, data matrix codes, and other complex symbologies. These camera-based scanners, often called area images, take a picture of the entire barcode at once rather than scanning across it line by line. They can read damaged or poorly printed barcodes, work at any angle, and even capture barcodes from smartphone screens. However, even these systems often include red light as part of their operation because it remains the most reliable method for reading traditional one-dimensional barcodes quickly and accurately. In high-speed industrial settings, like warehouse sorting systems, airport baggage handling, or manufacturing assembly lines, red laser scanners are still strongly preferred because they can read barcodes on fast-moving objects with exceptional precision. Some of these industrial scanners can read hundreds of barcodes per second, tracking packages as they speed along conveyor belts at high velocity. The technology that started in the 1970s continues to dominate because it simply works extremely well for its intended purpose. It's also worth noting that the standardization around red light created a positive feedback loop. Because red became the standard, barcode printing standards were optimized for red light scanning. The inks used, the contrast ratios required, and the minimum bar widths were all designed with red laser scanning in mind. This meant that as long as a product had a properly printed barcode, any red light scanner anywhere in the world could read it. This universal compatibility is one of the reasons barcodes became so successful. A product manufactured in one country could be scanned in any other country without compatibility issues. The Global Trade Item Number, or GTIN, used in retail barcodes follows strict standards maintained by GS1, an international organization, but the physical reading of those barcodes depends on that reliable red light interaction that has remained consistent for decades. The economic impact of this seemingly simple choice cannot be overstated. Barcode technology, powered by red light scanners, revolutionized retail by dramatically reducing checkout times, nearly eliminating pricing errors, and providing instant inventory tracking. Before barcodes, cashiers had to manually enter prices for every item, a process that was slow and error-prone. Inventory management required physical counting and manual record-keeping. With barcodes, a store could track every item from warehouse to shelf to shopping cart with unprecedented accuracy. This efficiency allowed retailers to reduce labor costs, minimize theft and shrinkage, optimize stock levels, and ultimately offer lower prices to consumers. The supply chain transformation enabled by barcodes helped create the modern globalized economy. All of this was made possible, in part, because engineers chose red light as their scanning wavelength and built an entire technological ecosystem around that choice. The use of red light in barcode scanners is a perfect example of how scientific principles, technological availability, and practical needs come together to create a standard that lasts for decades. Red light provides maximum contrast with black ink, works perfectly with affordable and reliable silicon-based sensors, has the right wavelength properties to handle imperfect surfaces, and remains visible and safe for everyday use. What started as the best option available when the technology was new became so effective that it never needed to change. The decision made in the early 1970s, based on the lasers and photodiodes available at the time, turned out to be so well suited to the problem that even with 50 years of technological advancement, there has been no compelling reason to abandon it. Every time you hear that beep at the checkout line, you're witnessing a small triumph of engineering, a solution so perfectly matched to its task that it became invisible through its own success. The red light isn't just a design choice, it's the right choice, proven by billions of scans every single day in stores, warehouses, hospitals, libraries, and factories around the world. It's a reminder that sometimes the first solution, when properly thought through, can also be the lasting one. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution.